any hopes, fears, things you have for next year. We don't have a formal presentation for you, but we're going to get the computer set up so we can actually pull things up if you'd like to look at it. So, does anybody have any particular things that they want to talk? Well, actually, let me just kind of show a hand type of things. How many of you program in Java? Okay. How many of you program in C++? It's okay. All right. How many program in LabVIEW? Okay, half. So, all right. Yeah. And I'm sorry, half. So,
I think there's another room for LabVIEW right now.
that's right. So thank you. So yeah, you're in the wrong room. If you're doing C++. Does anybody program anything else like Python or anything?
There is a discussion on LabVIEW happening in D, so you might want to go to that. And the people that are in there are really good. So,
I'm sure everybody. So I am what's known as I do. Sorry, this is going to seem a little weird. But I'm a lazy man. Okay. All right. So it means I don't program the robot. These ladies do on the fireworks, so they do all the real work. So yeah, it'd be interesting to maybe get a little discussion going about. So everybody here is pretty much programming in Java, and the majority of you are familiar with programming. So if you haven't, that's okay. This is a great resource, and one of the nice things about FIRST is the ability to reach out and talk to other teams and get information. I think you're all probably familiar, or most of you are familiar with. You can go out and look at any code online, because if you want to reuse your code, you have to make it publicly available for the next season. So there's tons of stuff out there on GitHub as resources, and of course you have each other. So are any of you looking to do do something different for next year that you want to talk about in terms of, or something cool you want to share in your code? Is anybody doing Swerve? Okay. So just to kind of to get a topic going, would you be willing to talk a little bit about how was it programming for your Swerve drive? Yeah? Easy, hard, things to know about?
Well, say we talked about this in the previous thing. I think our approach was to we've got individual units. We use the Talon SRX controllers, and we use the PID from those controllers. And so this way we can offload the processing for steer and for wheel velocity to those controllers. This way, our control code only has to basically come up with, I guess, the vectors for each of those 4 drive units. And then that way we can kind of modularize our code so that we have a 3-axis joystick, and so basically the twist and the displacement gets translated in our transform code to those 4 vectors, and then those set points then are just distributed to the 4 units, and that's worked very well for us so far. We did start with code on GitHub.
Okay.
We looked at what other teams have done. We looked at white papers, stuff like that, and then modified as needed. But that was a good approach.
Was there any particular team that you thought had a good framework or methodology that you liked? Yeah. You'd share with everybody?
I wish I remembered. We have. We actually sort of compiled like a couple. There's this one presentation floating around on Chief Delphi. I forget.
Ether?
Ether, yeah. That lays out sort of the underlying math for Swerve very succinctly. And that was where we sort of based our transform code, taking like joystick inputs and converting them to vector set points. I think Strikeforce also has a fairly robust set of examples, and their third coast library is also very helpful just as sort of a model. I think those are sort of the resources we've gone on.
Do you guys know offhand what the libraries and the object types that you're using to implement Swerve?
What do you mean?
So if you're using a base class to control each motor, is it just strictly, are you implementing the motor controllers and then writing algorithms around them, or is there a library that's out there that's like, import this and you have Swerve drive?
So there are libraries like that. We're not using them. I think Third Coast is a library for Swerve. I think there are a couple others. I don't remember their names offhand. we found, I mean, a lot of our infrastructure, the Talons provide a lot of sort of the, you know, busy work for you. So there's the abstractions that they provide, we rely on fairly heavily. But we have a class for the like Swerve modules, which sort of matches the modularity of those. And then we just have like our drivetrain class that instead of having 4 talents has 4 Swerve modules. Okay.
Yep.
So now we can pull things up if we want to look at that. So what was one of the team strike force you were talking about? Do they spell it weird, or is it?
Yeah, they do. They spell it with a
They spell it with a
Y.
Y. I just like that.
Strike force, yeah. Their library is called Third Coast.
I'm sorry.
Third Coast is their library.
Like that, Third Coast?
Yeah.
You guys get to see me type all the time. So they're on GitHub, and most people know about GitHub. So some sample code there. So this was very helpful for you guys. Yeah. So. Is anybody looking to do Swerve in your team? Show of hands. Okay. You ladies are making me nervous. For competition season. All right.
Just a suggestion.
Yes.
I mean, if the math can look daunting, but that paper by Ether, if you just do FRC Ether Swerve on Chief Delphi, I think you might be able to find it. He lays out the vector math pretty well. It may look daunting at first, but I suggest that you take the time to try and grind through it so you understand what you're trying to do, even though you might use someone else's code, because it's going to be very difficult to debug that code if you don't understand the underlying theory.
It's that, the first one.
Is this one paper?
Paper forward, yeah. And the file is the derivation of inverse mathematics.
It was
And the first download under that host is the derivation of the
There you go.
inverse mathematics. So we found that PDF, right?
Dangerous of using someone else. All right, so this is the. There you go. Does anybody refer to the sides of the robot as forward and starboard? I think we should start doing that.
It's gonna be a water game this year, so it's perfect.
Yes.
Well, these are some really good resources, it looks like.
It's The good thing about it, though, is that for the vectors, they're basically at each drive unit there are 2 vectors. One that causes the thing to spin, and the other that causes the thing to translate. And you can do those independently. So you can, you don't have to try and like the big bang debugging of this. You can sort of isolate those 2, debug each. So it's not as daunting as it might look at first.
Yeah.
So
This is not for the rookie team.
Right.
It really isn't.
Now, not to put you on the spot because it's always hard to get guesstimates in terms of that, but like, how long did it take? Would you say? So.
The course of this fall,
Okay. So, and you guys meet once or twice a week, or
once a week, yeah.
So this could definitely be done in the off season because you guys have done it. So.
I think you definitely want to start the off season and get a, kind of a mature implementation of this before. This is not something you want a science project you want to take off in the season.
During build season. All right, so there's some resources there.
What's the primary advantage to this type of drive?
It's incredibly well. It's incredibly maneuverable. I mean, the thing can spin and translate at the same time. It's really cool to watch.
So do you have to, what level of difficulty or just skill level of the driver do you have to like properly take advantage of this?
This is something you have to train on. This is not something you do 5 minutes in the hallway. Once you have to actually train on this to really get an advantage of it. I mean, there are multiple modes of the way this can be used. Like it can be used like you call it own chip up or field oriented, where it will stay pointed in the same direction no matter how you move. And then the other where you can, it's like own chip up, where it's kind of like tank drive. And flipping, I guess there are advantages to both of those. And there are things where you can actually spin on one wheel, kind of rotate around it. So if you're, in a pushing match with someone, you can flip around them. I mean, but that's not something your driver's going to do, without any practice.
Sure.
We talked a little about Swerve. Is there any hot topics programming wise? Anybody burning thing? I mean, we have a big change this year with. Go ahead.
Can we talk about cameras? Because I know some teams in this room had like amazing vision processing systems, and we had a vision processing system, but we didn't get to finish it before competition, so we just had the cameras. So could somebody talk a little bit about that?
Who's got some good vision they want to talk about? Yes, you in the back.
I'm from Top 18, Vulcan. We had a pretty rather simple approach to the vision last year too. We didn't have a full procedure, but we built a pretty robust near field docking system. Right, there are many spots on the field with the visual tape that you can dock towards. So what we did use the Limelight, which is the first generation, but they're pretty much the same thing. Through the network table, they basically just gives you variable that you can store into your main program. Several things that we found very usable. This TV for visual target, like if it sees something at all. There's A for area, and I think there's a length on X and Y too. Wait, no, that's the position of the object relative to your camera view. So basically what we did is just to tell the drivetrain to steer based off of the position of the object relative to your camera view, and to advance based on the area. However, we later decided that was not good enough, so I put an ultrasonic sensor on the bottom of the robot to aid that process too. We started thinking that we were going to use an optical sensor, but then we realized the whole field is built out of acrylic. Light shine right through and never come back. So we use an ultrasonic sensor to build that docking procedure. You do need to calibrate it at every event and hope that the lighting doesn't change. But once you do that, it's actually very reliable, and the logic is very simple. That's the product.
Just so people don't know, can you tell a little bit more about the Limelight? It's a solution that you purchase.
Yeah, it's pretty expensive. It's like $300 or something.
Yeah.
Can't remember. It passed. It uses the network switch. It passes data back to your RoboReal wide network table. It's easy access there. It's created instance every time.
Yes, in the back.
One of the mentors actually from Daisy told me, if you don't want to buy it, you can really just take the image and put it on like a Raspberry Pi 3. If you don't want to buy it, you just look at everything else, because like that's like way too much money. A couple of the images that came out lately though are kind of better in some senses. Chicken Vision came out. That's really good. They have angle of attack and everything implemented. Chameleon OS has been making like really big jump, right? Like everybody's been coming up with that. I've been working with one of the teams, I think Gearhead's 1189, and they're doing this thing called OpenSite. I like it right now. It doesn't have everything in yet. most of these things are using like MJPEG with last year's bandwidth being like 4 megs, so it's kind of trash with MJPEG because you got like what, like 10 frames maybe max. So some of these guys are like trying to implement H.264, but like some of these open source things are just kind of blowing limelight out of the water, especially with price. Like since people can add whatever they want to it, it's basically just like whatever you want, and it makes things a lot easier. Like because it has angle of attack and stuff, so you don't need those ultrasonic sensors. You just gotta plug it in, it calculates the distance, and from there it's. I mean, you can still use the ultrasonic sensor.
I use the ultrasonic sensor mainly because when you're too close to the target's actually bigger than the camera field of view. So you can't tell how close you are anymore at that point. Do you do the co-processing on the Raspberry Pi on board that's in the back?
It's on, yeah, most of these just run on the Raspberry Pi.
Okay, we've done that before, but we've run into some pretty significant latency issue.
Yeah.
I don't know, you guys might have done.
I haven't used any of these images, I've just
Okay.
images. We used the just basic Raspberry Pi thing last year, no processing or anything. We just put GStreamer on it and got 1080p, but we didn't have anything better than that. And the coolest thing we had was 1080p, that's about it.
So Raspberry Pi's what?
Yeah.
$40? Yeah.
I will say one issue that we ran into with the Raspberry Pi was the power wire. If we got like hit by another robot, the power wire tended to like pop out a little, so we would lose all of our cameras, especially in Sandstorm when we were like coming off the second level of the like the stairs. We would often like lose our cameras like at the beginning of the match. They'd be useless to us for the rest of the.
A possible solution is getting a PoE hat adapter for it. The newer versions of the Raspberry Pi 3s and the 3B Plus have PoE headers. So you can just slot a little adapter on there. They'll accept the 12 to 48 volts. So you can just buy the PoE injector and just attach it that way.
Was it Pee-wee?
PoE hat.
Pee-wee Herman?
What's that?
PoE.
Yeah, PoE.
PoE. PoE in jail, sorry.
Oh.
Yeah, that's not going to be good. Alright, so.
You can also just backfeed 5 volts of the GPIO pin.
Yeah, that as well.
Doesn't the new Raspberry Pi take USB-C power?
Yes.
Yeah, just plug it in from
But you
the.
still have the same issues with micro USB's retention force is not going to be high enough for the forces that you encounter on the match.
I'm not pushing Amazon, I just. So.
There's a couple different models you can find, but there's one through an extra company that actually slots on the GPIO pins.
Others? Oh, go ahead.
Someone explain the limelight or whatever. What is the control, the architecture of this? What's coming out of that limelight? How are you controlling your bot? I mean, how are you?
The Limelight itself is just a camera with a processing on board.
Well, what does it do? I mean, what does it process for you? I mean, is it providing contours?
Yes.
Okay, but then what do you do with that?
You can access those. They come with a set of parameters that they can just push back by itself. Like, for example, well, you have to tune it beforehand to have like a web interface that you access to the camera and tell it how do I filter the image, what kind of object I'm looking at, and I'll be finding, and it basically you draw a rectangular contour on the object that you have filtered out, and then what it would then do is to find its relative position to the whole camera frame and give you the X, the Y, and I think it has like a whole bunch of stuff that you can find in their documentation, and you can do your own calculations too.
So from that you can derive an error. You know, here's what I want to see.
Mhm.
Here's what I'm seeing. Here's how
Yeah.
I move my bot to fix that.
And it makes it really easy for new teams. I've never done vision before. We got this together, and me and him were both able to set it up in program and implement vision. It wasn't perfect, but you know, for first year trying it, it was definitely worth it. You were able to implement it. They give you code to actually calculate your distance based off the area. Calibration is key on that. We figured that out, but you know, it made it easy to get started and get an understanding of how to properly implement something like that.
And then you're just getting that from a network table. So you just pull up the network table API and say, give me the Limelight network table, and it's going to give you all the parameters. It's already calculated for you. You can say, oh, you know, your X pixels or whatever whatever to the left, you know, calculate the pit loop based off of that error, center yourself on it.
It takes a lot of the heavy lifting out of vision control. It's as much of a hardware package as for the software. That's what we're paying, I guess.
Other stuff on vision?
I have a different topic.
Yeah, no, okay.
So I was in here last year. Dogma did their presentation on Pure Pursuit, also on algorithmic autonomous approach. So I tried to implement that, but their code was in LabVIEW. And has anyone been here last year or has heard of their approach? So basically, you define a path that you want the robot to go, and then using their math, the robot will generate the best curve to follow that path that's at its best. So it's very different from a traditional, I don't know, time-based approach where you run the robot for 10 seconds, turn, run for another 20. It will generate the power for each side of the drivetrain if you're using a tank. It's generating the power for each side of the drivetrain and pushing the robot like that. Yeah, path following algorithm basically. Has anyone in here, because I have not successfully done it yet, has anyone in here have any experience on doing something like that? Shed some light to the situation. Last year we got out of autonomous because of sandstorm, but I don't know if we are going to do that again this year.
So, and there's some, I guess there's some additional libraries if you use the Talon SRXs for path followers.
There's also, I believe, there's also a pathfinding algorithm that comes with the FRC standard Java library as well.
So this is the WPI site where they've got path followers.
I know my lead programmer was looking into it over the summer, and your robot has to be mechanically pristine. So, like, no wiggle room. Like, there can't be, you know, it has to be solidly constructed. It can't be can't have, you know, it has to be within very tight parameters, and it can't be changing. Otherwise, you're going to be reprogramming it every time. So the idea is, you know, as I said, you trace out your path, and you're like, okay, go do it. I think it kind of goes without saying that if things change mechanically, that's not going to work.
It would be the builder's fault.
100% of mechanical problems can be fixed by programming.
So I assume while LabVIEW is a little hard to look at their code online.
I've never done LabVIEW.
Yeah.
I just.
Does anybody miss autonomous? Right.
Do you have any tips for like making a autonomous procedure? Because I'm a new programmer actually.
Yeah.
Last year is my first year building the whole program.
I'm pretty new too. I only miss it only because I feel like we had 1 year. I think we did okay autonomously. We got across, you know, I guess it was 2 years ago. We were able to get a cross scale cube, which was pretty exciting. That's about the extent of what we were able to do. So this year I feel kind of cheated because I wanted to build on top of that momentum with the programming team, and we just took it out from under us. So that's why I missed it. We just found a paper by one of the guys who helped write the API in Java. He actually gave it to my lead programmer, gave him the link. It's control systems. I'll give you the name of it, I'm sure. Controls, Engineering, and First Robotics Competitions by Tyler, I don't really get his last name, Finesse.
Tyler.
Yeah. And then last name V-E-N-E-S-S.
Yeah, I'm gonna need that again, I'm sorry.
Oh, V-E-N-E-S-S.
He's got his own site, and I'll get him. You go to GitHub or go to his site.
It's probably on his own site.
Hi, Tyler.
Well, maybe not.
Yeah.
My latest PDF is available.
There we go. Latest PDF.
It's gonna be a page. That's looking at live.
That is it.
There we go. All right.
So I've been working, it's just a light read, 290 some pages.
Congratulations.
Well, but he goes over everything, and he doesn't take the.
What else is the text is? He's got pictures. A lot of trees.
The idea is to teach high school students control systems. So going into it without having an idea of controls, that's fine. He explains all that. He goes over the nomenclature, goes over how do you tune the pid group, how do you work with feed forward. So I'm hoping we're going to be able to leverage this year in some type of autonomous.
It's a challenge.
How many people use command-based programming as opposed to time-based?
Most folks know about command-based. How would you describe it? Yeah.
It's basically an object-oriented form of how you would program a robot. Essentially, you're dealing with much like when you're looking at an object-oriented design, you're going to want to break it down into its base components. So what command-based does is you have subsystems, and then you have commands, and you tie them together, and then you link them together through your IO,
It's a set of instructions that implement a control flow, and whatever you want that control flow to be, how you build out your diagram of the discrete steps of the things that you want your robot to do. You build each of those steps into its own module, and then as the robot goes through and encounters things in the field, it will then execute those modules to kind of go down the control paths that you have predefined for your robot to follow.
More or less event-driven?
Yes, more or less event-driven.
Yeah.
And it can be helpful for team programming, because you can assign a programmer to a subsystem. So
Yeah.
someone can work on a drivetrain, someone can work on an elevator, work on
If you have a bigger programming team, it's very helpful because then you can very easily delineate programming tasks. Right?
Yes.
So I have a question for everyone. We're a new team, 75-99, and so we're going into our second year. And one of the things that we encountered as a problem last year was that we had one Rio, and when that was being worked on or being integrated into some other system on the robot, the programmers couldn't touch it. So how do you guys do testing and verification and validation without having a Rio to flash to and interact with?
Yeah, go ahead.
So we haven't actually used it yet because it requires, we used to use Autodesk and or convert your files over to Autodesk. But there's this thing called synthesis. Yeah, a lot of people come with convert because it's basically, it emulates everything, Aurora and everything. It uses Unity engine, if anyone does like game development here, and you can basically import your Autodesk model or your Autodesk model into it, and just you assign, I think, parts to it or something, add the music, and you like assign certain parts to certain subsystems. From there, you can actually use your controller and just go. You import a 3D model of the field, and you just kind of hit the button and go. It takes a little bit of setup, but once you get there, if you have a lot of issues, because I know we did with actually getting hold of that Rio, like it's definitely worth putting like a few days into.
So does that require additional programming and like different languages to get set up? So you can take your Java, compile through VS Code, and then.
It requires your modeling to be very, very accurate and completed.
Modeling in what sense?
Your CAD on the robot.
Okay.
But the programming side is all like, it's basically the same thing as running on the actual robot.
So that doesn't sound like something that you would start now.
Yeah.
That would be an off-season thing that you get going. I mean,
Okay.
for you right, I mean, how big a programming team do you have?
Minuscule.
My suggestion would be focus on unit tests as best you can. Object-oriented abstraction, code to abstractions instead of to specific hardware devices, because obviously if you don't have hardware to communicate with, but if you code to an abstraction, then in your unit tests you can mock up a motor controller or whatever you need to do, and then you can flesh out a lot of the testing, your base level testing that way before you ever have to actually get on hardware. Okay, you want to do as much of that testing as you can, because obviously you don't have, it's a hardware resource contention issue.
Mm-hmm.
And then schedule your time, maybe you can schedule time for your programmers.
What is the mechanical team doing to Rio that's not programmed?
Well, originally last year it was kind of just building it into the electrical system. So
maybe build a design where it's accessible, or at least the electrical system might you could take that whole board out.
yeah.
Build that as part of a design goal, so that way your programming team can actually have it. They can power the motors independently. They don't, they can just bring a battery over.
Is that something, will we get a second Rio in our kit parts? No. So we have
buy
one. Okay.
I would, if you can do it, you can swing it. I would make that priority.
Yeah. I had this idea during the summer of actually trying to get some people together and build an emulator. So it's the processor on the Rio is a Xilinx FPGA with an Atmel A8 Cortex processor on it. And so there's a system that's out there that's called EMU. It's a processor emulator, and that has a module for a Xilinx processor. And so it would be cool to take the firmware that gets flashed onto the Rio and then build that into the emulated system, and then everyone can just have a software emulated processor of the Rio. So you can get around having to have physical access. You can program it and run tests on that emulator. So
if you've got programmers with the skill that you can build your own emulator, I'm not sure that programming is necessarily a weak point for the team.
Sure. That was just an idea that I was kind of throwing out there, but maybe next off-season.
What is so special about uploading the code onto the Rio?
Just being able to interact with it and see it run and get input and feedback and see how be able to validate the code.
Yeah. I mean, at the bare minimum, you can look at the controllers, right, and be like, oh, I'm pushing forward on the controller. Am I getting if you're using talents, am I getting green and red so I know that I'm going forward? We actually had an issue with our demo bot where we had to actually go that far because it wasn't working, and it turns out that somehow 2 of the motors got reversed internally. So we had 3 motors going forward and 1 motor going back. It wasn't a programming issue, I'll have to say.
Software you use, we don't really use it at all over here. It's just something called a strong back. We use it, but it's kind of sometimes use it first. So you want to write it down.
Okay. Strong back.
Strong back.
So we had a mentor who, his availability has been limited. He's a big advocate of it. Wait for him to come back so we can learn.
What was this? You guys said something about strong back?
Strong back, yeah. It's a unit testing interface, architecture.
The code
great stuff. Someone had their hand up?
Well, if we're good with changing gears a little, I just wanted to ask if anyone, I know there's been, especially in the sort of command-based area, but also in general, a fairly major overhaul of WPI Lib for 2020. And we haven't really gotten to look at it that much, and I'm wondering if anybody has like had a chance to play around with it and see sort of what's changed.
I've been asking this question, I haven't gotten an answer. Do we know of any teams doing in our area in Mid-Atlantic doing the beta test this year? Because usually those teams, if there are supposed to share that information publicly. So it's kind of sell. Okay. I don't know who they are. We'll find that out. Great. Yeah, I hear as well. There's going to be this big overhaul and so how now? You get the updates you're saying, or
I subscribe to the WPI library GitHub, so I get email every time somebody does a push or commit.
and that's publicly available. Yeah. So you can, what you can glean from that, might be something. I mean, we should start hearing pretty soon about if you think of last year, I think late December they had the new control system out a little bit early in advance of kickoff. So hopefully we should hear soon. It's December already. If there are going to be a new drive station, I assume, and what the changes are, and if they're going to do anything that breaks code.
Well, there's a doc online that we they have published this sort of list of changes.
Oh.
It's like WPI Live New for 2020. But we're anybody that actually got that on that.
There we go. We got the paid holidays.
Yeah, live.
Put FRC in there. There we go.
Command-based framework has been rewritten. There's a design rationale we can find here. I'm not going to go out for that. Now support vendor libraries rather than built into WPI itself. Linear digital filter. New PID controller.
That one I think is pretty cool. Like they pull it out of the vendors and build one themselves, and so it doesn't matter if you're using Rev or Talons. You can just use their head controller.
Are we required, or do you want to use this?
I'm guessing if you want to use it, I don't think it'd be required. That doesn't sound right. I don't know.
So there's some new kinetics classes for swerve, mechanism, and differential drive, and odometry classes. I'm going to pronounce this wrong. Ram static controller for closed loop feedback for unicycles. Okay. Real-time trajectories. Checks a lot of drive. Oh,
The answer's redundant.
boarding class. You remove sample robots, if anybody was using sample robots. Null checks are more descriptive. Remove deprecated live window functions. Definitely, so they did some more PID stuff. Iterative robot has been removed. That's the time robot. Shuffleboard. How many people use? Does anybody in terms of how you do? Yes. Okay. This seems a little buddy.
Usually after restart.
Yes.
Once or twice
Yeah.
turns out.
Restart issues. Looks like we're getting a new Raspberry Pi image. So. So we still got some bug fixes. There's an all-in-one installer. That's welcome. And we got a code extension image student. and there's support for PWM with the Sparks. Other topics, things you'd like to see improved? Anybody doing anything different in terms of, are you hoping, unless you're the team that always has plenty of time to program the robot.
That's fine.
So with the removal of bag and tag, you're hoping to get some more time, are you still looking to robots?
How many, how many teams built 2 robots? One for programming, one for.
It doesn't work out that way. Sometimes it's 2 for the.
One for screwing around, one for built to fit.
I find that the issue with 2 robots is like last year we had 2, and we had our like practice robot is what we call it. We programmed it with like all the values and stuff, and then we had to go back in with the new one because they weren't exactly the same and like reprogram almost all of the values. So that was one downside to having. It was nice to get like the logic and like the actual code, but going back in and like, so if you're gonna do 2 robots, I'd recommend defining like variables for like numbers so you only have to change them once. Because that was something we ran into. We had to go and change every value individually because we didn't have the foresight to define them as numeric.
For software development, that's a good practice, not just for robots.
Was it also with like robot map and everything, or just like?
No, I just said I'm sorry.
Just like it was a robot map, it was like cool. Like isn't that good practice?
We put all our constants in there.
Yeah, everything's constant.
Yeah, we have a constant that's going in there. So there's, in the command-based structure, there's an object called robot, and it just holds all of these constants. Kind of what you're suggesting.
Does anyone use the config file they load at runtime instead of hard coding?
LC does. Yeah, you guys, yeah.
So how do you do it?
There was a session on that years ago.
First you have a config file for everything. Then you have a Wing SAP. And it's, I don't even have access to Wing SAP, I don't know why. But yeah, it's our laptop, it's Wing SAP, and you have our the password, get in there, and you have the config files, the values for, it's like pretty much everything. And it's a good thing so that like, it's easy even for the drivers or someone who doesn't know how to code to change the values. As long as you mentioned, well, some part you can change, some parts don't change that at all.
Is that XML based file? I mean, what
I think it was INI file. Last
check that out.
time, I think it was just an INI parser.
All right.
And then just FTP.
That way you wouldn't have to change code.
Yeah.
Bot to bot. You could just change the bot.
So that presentation should be probably out on LC's site, I think, a year or 2 ago. Anybody else doing config file? How do you guys like Visual Studio Code, for those of you who've been around for a while?
Love it.
I can bear with it.
I think there's a new online Visual Studio Code just in the one. Yeah, I think it's online. You can do a web-based now for Visual Studio.
I'm sorry?
Like for VS Code, you can do like web.
You can do it in the browser.
Like online, not like down. I think it's just for like in the one, but.
I thought they did it for Visual Studio, but not VS Code. Like the CID. I might be wrong.
Yeah, I might be wrong either.
I saw that news. It's pretty cool. They have a whole web-based IDE now. But no use to me.
Well, we think it's just for full version.
It says it's a companion to both Visual Studio and VS Code, but they're calling it Visual Studio Online.
stuff? How many guys use GitHub? There's a session on that too, so if you're not using it,
On the subject of control system, I'm noticing a bunch of teams doesn't use they're still using command base, but they're not using the recommend or the standard WPILI FRC structure, like the robo class, the IO class, the robo map, and all the standard ones. Have any of you guys looked at any of those? I'm trying to adapt to, so it's from the same effort of me trying to do the autonomous code. I found a team, I think in California, that implemented the Optimus white paper in Java in another library, but they did a separate form of control system that is not exactly the same as what I'm used to seeing. So,
what team is that?
Warrior something.
3256.
3256. And they have a GitHub. Warrior boards, yeah. I think they might have they took that from Cheesy Food.
One more time, FRC. Oh, here.
If you go down there, they have FRC programming 2019 is the one that I'm modeling off of.
Like acid.
Yeah. 19.
Here you go.
Yeah. There it is. Yeah. Under robot, they declared their subsystems differently. They wrote their own base, I think. So the subclass is not of the WPI's subsystem, but a different one. It's kind of confusing because it's not documented. But I'm kind of following the thread.
Yeah, they really didn't.
Wow. Scroll.
This is a drivetrain code.
Oh, and the tally op is handled in a different way too. Like they don't have the input-output class, so they don't bind their buttons there. Rather, they do a tally op handler or something. I forgot what they call it. The tally op updater, yeah. It's confusing.
How are we doing on time? This is we're about 2 minutes out. Any last minute things that we want to talk about? All these tabs are open if you want me to copy it down. So, all right, thanks for coming. Appreciate it. Thank you. Enjoy your next session.